All right, so now we're going to find the area of the triangle below, round your answer to the nearest hundredth. So before we even start, let's review what's the area of a triangle. Area of a triangle is 1/2 base times height, or you might have seen it as base times height divided by 2. So the area of a triangle is half that of a quadrilateral. All right, so looking at this right here, this is the base. The height is always perpendicular to the base. All right, so in fact, we don't know either the base or the height. We know part of the base, but we don't know the height at all. But what's so great about right triangles is that you can find them in a lot of places. All right, and this is why Pythagorean theorem is so important, because I'm going to use Pythagorean theorem. We'll call this the A, B, and C. So we have a squared plus b squared equals c squared for this red triangle. So A is what we're trying to find, which is the height. B is 9 centimeters, and then C is 12. All right, so identifying a right triangle, plugging in things we know, and then just computing from there. And 144 minus 81 is, hold on, 63. All right. Take the square root of both sides, and A equals the square root of 63. And we're going to keep it like this. It says round to the nearest hundredth, but for now, we are just going to keep it in radical form. All right. Why are we doing this? You'll stay tuned and find out. All right. So now we know the height we're going to call radical 63. Now the base, we got to find the other part of the base. So what we're going to do over here is this. All right. And we'll kind of keep things the same. I'll call that A is radical 63, B and C. So in this particular case, we got A squared plus B squared equals C squared. A squared, so we have the square root of 63 squared plus B squared, which is what we got to find, and then C is 11. All right, what's really cool is that the square root and square undo each other, so you just get 63 plus B squared equals 121. 121 minus 63 gives me B squared equals 58. Subtracted 63 from both sides. So that means square root, B equals radical 58. All right, so what I like about this problem is that we have to be very precise about things. All right, the height is square root of 58. The base is 9, oops, timeout. The height was the square root of 63. Square root of 63. The base was 9 plus radical 58. All right, so I'm going to wait till the last second to round. All right, this is kind of a good skill as you guys progress in your math career. It's going to be 1/2. Base is 9 plus radical 58. And then the height is radical 63. If you can wait till the last second to round, we're going to have a lot of success. So like just knowing how to use a calculator, this is one of the reasons why I absolutely do not like iPhone calculators. It makes it harder to do this stuff. Is actually, let me just say it like this. What it's going to look like, there's multiple ways to plug this into a calculator. Maybe you just want to do this, parentheses 1/2, parentheses 9 plus radical 58, close parentheses twice, because notice how there was 2 opened up, and then radical 63, close parentheses. That's what it should look like when you plug it into a calculator. All right. If you can plug it in like this, you're going to avoid rounding errors, which is something we want to do as we progress in our math careers, and we have to be more exact about things. And then we're going to get about 65.94. All right, kind of a tough problem, but nonetheless. All right, this one right here is the same kind of problem, just a lot easier. The base of this triangle, the base equals 10. The height, we don't know this. And this is probably this gray triangle that I'm just emphasizing right now is actually the most famous triangles of them all. We'll call the height B, that 3, and that 5. So A squared plus B squared equals C squared. Why is this the most famous triangle out of all the triangles? Ancient Egyptians knew about this triangle. They utilize it to build right angles. Why? Because as you can see, we get the 4 smallest numbers. We get 3, 4, and 5. 3 smallest whole numbers that satisfy Pythagorean theorem. So the height's 4. The base in this triangle, we have 3, 4, and 5. Pythagorean triple, 3 whole numbers that satisfy it. But nonetheless, the height's 4, the base is 10. So the area of this triangle, 1/2 base times height, significantly easier. It's going to be 20. All right. So that's it for Pythagorean theorem. Now we have some quick review of Unit 3 stuff. We're kind of getting towards the end of the year. Some stuff we just got to keep fresh in our brains is, given that A is parallel to B, find the value of X. So remember, this is a transversal. It's on alternating sides of the transversal. It's on the inside of the parallel lines. We have alternate interior angles. Now, what's so great about alternate interior angles? They're congruent. So here, all we just say is 5x minus 54 equals 6x or 3x plus 16, and that's the setup. All right, if you can remember that, we're in good shape. It's really this equation what I care about setting up the most, because then we're just going to subtract 3x from both sides. Add 54 to both sides. We're going to get 2x equals 70. All right, so alternate interior angles, we're actually going to see these more throughout the year, and the air test is coming up and some other tests. So it's just good to stay sharp and review some of that stuff. Now in this one right here, I kind of wrote over top of it, find the value of x. Well, notice in this case right here, it's telling us the lines are parallel. That's what those arrows mean. All right. So notice how, in terms of the transversal T, notice how they're on the same side of the transversal and on the inside of the parallel line. So they're on the same side inside. We call that consecutive interior angles. And they're kind of the ones that's different than everything. They're supplementary. Consecutive interior angles are supplementary. That means they add up to 180 degrees. And we're going to be using this a ton in Unit 4 when we talk about parallelograms and stuff like that. So for this one, we're just going to say 2x plus 43 plus 2x minus 3 equals 180. Then combine like terms, 2x plus 2x, because look, we're on the same side. It's on the left side, so we're combining like terms. All right, 43 minus 3, 40, 180. Subtract 40 from both sides. Get 4x equals 140. And this is kind of crazy. Divide both sides by 4, x again equals 35. So it's just kind of a quick review. We're going to do that throughout this unit, have a quick review of this and that and this. Just keep our brain fresh